Welcome back. In this video, we will go over the microscopic anatomy of the skeletal muscle. For example, the biceps brachii is a skeletal muscle. Each skeletal muscle consists of hundreds of muscle fibers. Right here, we have one muscle fiber, also called myofiber. So the muscle fiber, basically, it resembles the skeletal muscle cells. Instead of saying skeletal muscle cell, we use the word muscle fiber, also called myofiber. Each muscle fiber is surrounded by a cell membrane. This cell membrane is called sarcolemma. So when it comes to the skeletal muscle, the sarcolemma is the cell membrane. Each muscle fiber is multinucleated, with the nucleus is flat and it is pushed to the side. So right here we can see 1, 2, and 3 nucleus. Also, we have a mitochondria. The mitochondria provides the energy needed for the muscle contraction. Each muscle fiber consists of hundreds of myofibril. Don't confuse myofibril with muscle fiber or myofiber. The skeletal muscle appears striated under the microscope for a reason, because we have the dark A bands and we have the light I bands. So the dark A band and the light I band, they give the skeletal muscle its striated appearance. Let's zoom on the anatomy of the myofibril. The myofibril consists of units. We can see right here each block makes a sarcomere. What is a sarcomere? The sarcomere is the contractile functional unit of the skeletal muscle. Each sarcomere, it extends from one Z-disc to the nearby Z-disc. In the center of the sarcomere, we have the H zone. This right here is the I band. Remember, the I band, it gives the lighter striation. So this is the light I band. We can see it right here on the myofibril anatomy. The I band is shared by two nearby sarcomeres. Whereas the A band, which consists of the two types of filaments right here, we will mention them in a minute. So the A band gives the darker striation. So this is the dark A band. Each sarcomere has the A band right here and part of an I band. So the I band is shared with two nearby sarcomeres. These are the M lines. The thin filaments are called actin, while as the thick filaments, they are called myosin. So notice how the A band, it has both the thick and the thin filaments, whereas in the I band, it consists only of the thin actin filaments. Again, right here we have one myofibril. Don't confuse myofibril with myofiber. Each myofibril consists of hundreds of sarcomere. This right here is one sarcomere. It extends from one Z-disc to the nearby Z-disc. In the center, we have the H zone. This is the I band, which is shared by two sarcomeres. You can see it on both sides. The I band, it gives the lighter striation, and this is the A band. Right here, we have the M line. We can see both thick and the thin filaments. Right here, this is the M line. These are the thick myosin filaments. We can see them right here with these tiny hooks so that they can attach to the thin filaments, which are the actin filaments. Also, right here we have the elastic titin filaments, which controls the degree of stretch in each sarcomere. Now let's zoom onto this organelle in the skeletal muscle. First, this right here is one muscle fiber, which is called a myofiber. We can clearly see the sarcolemma. Each muscle fiber consists of hundreds of myofibril. This right here is the sarcolemma. We can see the myofibril. This right here is also, you can see all these myofibrils. This is the I band. So the I band gives the lighter striations. This is the A band. A sarcomere extends from one Z disk to the nearby Z disk. This is the H zone. And this right here is the M line. We can see a mitochondrion here. The mitochondria provide ATP, which is needed for the muscle contraction. Now moving to these three tubules, this is the triad. Tri from three tubules. In yellow, we have the T tubule. Notice how it is connected to the sarcolemma, the cell membrane, so that it can deliver the action potential rapidly to the interior of the muscle fiber. These are the terminal cisterns of the sarcoplasmic reticulum. So when it comes to the skeletal muscle cell, instead of having rough and smooth endoplasmic reticulum, we have sarcoplasmic reticulum. Notice how the sarcoplasmic reticulum, it traps around each myofibril. Sarcoplasmic reticulum, it stores the calcium, which is an important ion needed for the muscle contraction. These are the tubules of the sarcoplasmic reticulum. They cover the sarcomere. So right here you can see one sarcomere. In the sarcomere we have the actin and the myosin.